Standard 3.5. Solve quadratic trig equations using special angle values or the calculator. All right, let's consider our first quadratic trig equation. Now we know it's quadratic because we see the squared there in our equation. And our first step is, let's take the trig out of this equation. So we're going to let y, I'm just picking a random variable that's not already in our problem, equal cosine x. And when we do that, our new equation is 2y squared plus 8 equals 17y. Since we see the square there, it's an indication that we're going to have to factor. And in order to factor, we want to set this equal to 0. So I'm going to subtract the 17y over to the other side, put it in standard form. Okay. Now we're going to factor. So we're going to set up our parentheses. Notice there's no common factor to 2, 17, and 8, so I'm not pulling a number outside the parentheses. Now the 2y squared is going to be broken down into 2y and y. So these two numbers have to multiply to 2y squared. And this blue number and this blue number have to multiply to make 8. Now there's lots of ways to make 8. 1 times 8, 2 times 4, or we can have 4 times 2 or 8 times 1. The order matters as well. We're not going to know which one is correct until we actually try it out. So let's try 1 times 8. And it's a positive 8, but a negative in the middle. So we're going to do 2 negatives, which will multiply to a positive. And we're going to do 1 times 8. So we can try 1 and 8. Oh, sorry, I see a mistake here. This should be 1y. Okay. So let's check to see if this is actually correct. Well, yellow times yellow makes yellow. All right, blue times blue makes blue. And let's see if we can get negative 17y by multiplying an outer pair here. That's negative 16y. And the inner pair, negative 1y. And these two add up to 17y. Negative 17y. And that matches our middle term, and so we know that our factoring is correct. So we have the factors 2y minus 1 and y minus 8 equal to 0. To solve a quadratic, your next step is to take each factor and set it equal to 0. And when we do that, we get y equals 1/2 and y equals 8. Now let's incorporate the trig back into our equation. So we're going to replace y with cosine x. Cosine x equals 1/2 and cosine x equals 8. And we're going to solve for x. Let's make this one in radians. So let's say that our restrictions are from 0 to 2 pi. All right, so to solve cosine x equals 1/2, we want to find the angle that has a cosine value of 1/2. We know that's 60 degrees or pi over 3, but that's our reference angle. We're going to sketch in quadrants 1 and 4 because that's where cosine is positive. And the reference angle is pi over 3. So the quadrant 1 angle is pi over 3, and the quadrant 4 angle is 5 pi over 3. And that's because 5 pi over 3 is pi over 3 units before 2 pi, which is written as 6 pi over 3. 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. All right, so those are two of our solutions. On the other side here, we have cosine x equals to 8. Notice this 8 is greater than 1. The limits for cosine are from -1 to +1. And so because cosine is greater than +1, there's no solution on that side of our equation. So we have only two solutions here, x equals pi over 3 and x equals 5 pi over 3. Let's look at a second example. So again, same method here. We're going to let y equal tangent x and replace tangent x with y. So we get y squared minus 7y equals -12. Before we can factor, we're going to set it equal to 0. So let's add 12 over to each sides. And the indication that tells us we're going to have to factor is the squared. Now this is a little easier because our a is 1. So when we're factoring, we can find two numbers that have a product of 12 and a sum of -7. And -3 and -4 meet those conditions. So we have y minus 3 and y minus 4 equal to 0. Now for setting up our solutions, we have to set each factor equal to 0 independently. So y minus 3 equals 0, y minus 4 equals 0, so y equals 3 or y equals 4. Putting the trig back in the equation, we have tangent of x equals 3 and tangent of x equals 4. At this point, you might think there's no solution because 3 and 4 are outside of the limits of -1 to +1. However, tangent is limitless. There are no bounds on tangent. Our tangent value is allowed to be greater than 1. So we're going to have to find our reference angle by using the inverse tangent key on our calculator. And let's do this one in degrees. So let's say that our answers has to be between 0 and 360. So if we do inverse tangent of 3, making sure our mode is in degrees, we get 71.6 degrees. And that's our reference angle. 3 is positive, and tangent's positive in quadrants 1 and 3. So the quadrant 1 angle is 71.6 degrees. And the quadrant 3 angle is 71.6 degrees past 180. So adding to 180, our quadrant 3 angle is 251.6 degrees. On the other side, similarly, inverse tangent of 4, and we get 76 degrees basically if we are rounding. So 76 degrees. And again, 4 is positive, so we're sketching in quadrants 1 and 3, but our reference angle is 76 degrees. So the quadrant 1 angle is 76 degrees, and the quadrant 4 angle is 180 degrees plus 76 degrees, or 256 degrees. So we have 4 solutions in this case. That's standard 3.5 solving quadratic trig equations.